Welcome to the first webinar of 2020. My name is Scott Mizsak. I am a Senior Technical Specialist here at ATG. Today's webinar, we're going to look at the CTC software, the Corridor Productivity Pack. While this productivity pack is now currently free and available to download at your whim, we wanted to go through 12 of the subassemblies just to show you what they can do, why they're better than out of the box, and let you know that, hey, you have the PKT and there's things that you can do with them to make them even more towards your software or your workflows when it comes to building corridors within Civil 3D. So we'll go ahead and get started. So again, the agenda or the main goal is to explore the benefits of the CPP by utilizing the additional features of the subassemblies. Now, this webinar is being recorded, so it will be up on YouTube or Vimeo in the near future. If you have questions, go ahead and put them into the chat. I will go ahead and look at them if I'm paying attention. And if I think that I should stop and answer the question right then and there, I will. If not, I'll just wait till the end. If I don't have any questions at the end, I'll prompt for more questions. So let's go ahead and get started. Not even going to bore you with PowerPoint. I'm going to jump right into the software. And I have 12 subassemblies that were custom built, and they are available in the CPP. Now, there are 10 of them that are built for Imperial and 10 of them built for metric. So these first 10 are identical. The bottom two, MnDOT Curb and MnDOT Curb with Sidewalk, those are unique to the MnDOT specifications. So there's no Imperial metric versus that. But there is another set inside the zip file that you will get that will give you Imperial settings or metric settings. So the first one we have is General Curb. And I'm just going to walk through each subassembly, and I'm going to look at it in properties. And what you're going to see in these properties is this is general. So it's not anything specific, but what you see is the insertion point. You have flange, you have top back. So as I make that adjustment, it makes the adjustment on where or how it's being built. This comes in really handy when you're dealing with medians. If I'm working across from one side of the road to the other and I have to go through a median, guess what? I can't always attach to the flange on there. The other nice thing about this subassembly is the fact that everything is spelled out. If you look at the general curb in the out of the box, it says what's dimension A, B, C, D, E, F, and such. This actually says, what is your gutter slope? What is the gutter width? The gutter thickness, depth of top, height, slope of face. So you know when I make an adjustment to one of those variables, it happens. So if I go gutter width and I make that 2 feet, guess what? My gutter just became 2 feet. I don't have to say, oh, that was dimension E. So this is a nice functionality when it comes to a curb, knowing what you have to build and the fact that there's flange or top back. Everything else, besides the dimensioning, is straightforward, but what you also have is codes, link codes, inside vertical base, outside vertical base, inside vertical subbase, and outside vertical subbase. So that means these verticals I can actually get rid of. So when I'm tying into a lane, I want the sand or the subbase to look like it's one entity, not having that vertical line separating the two. So if I set the verticals to be none, and then in my code set styles, I say if it's none, it's no display. Now it'll look like these are one piece. So the sand or the subbase and the rock or the base would all look as one on there. So that's your general curb. Link to mark point. Very simple. It gives you depth. It gives you link codes on here, but it gives you a mark point. What this allows me to do is to have a mark point called, in this case, P1, and it will go and it will automatically link to that. It is the mark point. It is the link to mark point The only difference between this and out of the box is that it gives you depth on there. And because I have depth, now I have two sides. I have a top and a bottom, and I have the ability to give it a point code for the top inside, outside edge, the link top and bottom, and the links inside, outside verticals, and then the shape. So all four links, the top two point codes, and then the shape all have the capability of being custom coded. Again, that code set style helps me now display it the way I want it to. Pretty straightforward on that. Going into link slope to elevation. Same thing as out of the box. Instead of it just being a link to an elevation, it has the ability to go, hey, if I'm in a slope scenario, 50%, slope cut scenario, 33%, and I have depth on there. And then elevation, -2 feet in this case, so it came down. And then again, I have the 2 point codes for the top, the 4 links, and then the shape. Very similar to that of, again, out of the box, but now it includes depth. And then all the links, points, and shapes are now customizable. Link slope to surface is the same thing as slope to elevation. I have cut slope, fill slope, but I have depth. And because I have depth, now I have a shape. So I have my 2 point codes again, my 4 link codes, and then the shape code on there. Link slope vertical deflection. Slope 3:1, vertical displacement 10 feet, depth 1/2 foot. Again, because of the depth, I now have a true shape, which gives me 2 point codes, 4 link codes, and a shape. Obviously, you can see that I haven't made custom codes, point codes for the 2 bottoms. Typically, the top are what's critical on there. Link width and slope. Same thing as out of the box, but again, we have depth. The 2 that I want to point out really quickly in here is the slope to elevation. Because if I come in and I make this, instead of -2 feet, I make it -20 feet. That shoots out 20 feet. Inside the PKT, you could come in and make a conditional in there that says, if this value is set, show this. If it's not set, show this. So you could come in and in the assembly here, you could have it just look like it comes out 10 feet with a vertical difference of 2 feet on there. So it looks consistent no matter what value you put in there, so you don't get big ones in here. It's something that I've made adjustments to other people's. We just never came back and updated the CPP anymore. Median. Median is nice. It gives you the ability to say gutter slope, gutter width, gutter thickness, depth, top, height. This does affect both sides on there. So you can't have a 2-foot gutter on one side and only a 1-foot gutter on the other. It is consistent across. But the nice thing about this is the gap between. If it gets wide enough, it will separate those out. Instead of grading straight across, it will put in separate ones in there. So gutter width, slope, subbase, depth, extension, distance between flange of curbs, 6.5 feet. So if I make this 10 feet, you'll see that it becomes 2 separate grading entities. I got my base and subbase on the west side, base and subbase on the east side, left side, right side. But when they get close enough together, 6.5 feet, not 63 feet, but 6.5 feet, it becomes 1. So it'll grade straight through. Very common, very typical up here in Minnesota, at least, that when the back of curbs are close enough together, they just grade straight through. Again, the curbs, the subbase, the base. I got my links for the inside verticals. Again, zero them out. So if I do have a lane on either side, which I would expect I would, I can make it look like one entity again. Multi-layered lane to mark point. I have the multi-layered lane, which gives me the ability to say how many lifts do I want. Right now I have 3 lifts on here, but I could come in and make it just 2 lifts. I can make it just 1 lift. Out of the box, you're set to just 2 lifts. Well, if you're building a highway, the highway may be consisting of 3 lifts on there. So we need that 1 extra one in there. And we don't want to use that generic pavement structure. We want to use something that is 1 entity. Maybe you're building a trail and it's just flat out. We're dropping in 3 inches of blacktop. We're running a paver over it, a packer over it, and we're done. It's 1 lift. Well, I don't want to zero out one of my lifts out of the box lane. So just by going to 1, I get that capability. Depth for the 3 lifts, and it's set up thickness of top lift, middle lift, or bottom lift. So that's how you know, because if I go 3 lifts, it adds 1 to the bottom. So this is always the top, this one is always the middle, or bottom if there's only 2, and then this one is always the bottom, because you can't have a middle one if it's when there's 3, that third one is always the bottom. The base depth, the sub base depth, all my codes are customized in there. Again, this is one of the big things about these things, is that out of the box there wasn't much for customization when it came to point, link, and shape codes. Now that they're customizable and I can build my own unique custom code set styles, I can make this look any way I want in the software, in Civil 3D. So if in the assembly view, I can make it look one way. When I'm editing the corridor, I can have it look another way by the code set style. And then when I'm ready for production printing, I can switch that to be something else just by putting in custom codes. Now, by default, we have used the out-of-the-box naming scheme, Pave 1, Pave 2, Pave 3, because if you're still going to use out-of-the-box codes, you got to have things match. So instead of making 500 codes, we're going to stick with the 75 out-of-the-box codes. And again, with this marked point, I have that capability of targeting a marked point called P1. Again, it's customizable, so I can do whatever I want to it. I can call it whatever I want. Pave 1, edge of travelway 1, edge of travelway west, south, whichever one I need, I can make it work. Sidewalk with boulevard, it's very similar to the out of the box, except there is now depth for the boulevards, or terrace if you're in Wisconsin. The other nice thing about this is all 3 segments had to be 2%. Now, positive 10 for the sidewalk, and then minus 10 for the outside boulevard or outside terrace. Gives me that flexibility on there, because it's not always going to be 2%, minus 2% across all 3 segments. I may want the sidewalk and the inside boulevard to slope to the road, but I want the outside to slope away from the road, because I don't want anything to really come onto the sidewalk on there. So this is nice with the fact that I have the flexibility of having independent control on each cross slope. With the capabilities, I didn't mention this on the other ones, but with all of them so far, they have the standard targeting capabilities. So I can target this point right here both horizontally and vertically. This point both horizontally and vertically, and then this one horizontally and vertically. The other thing that's unique to this one compared to out of the box was it actually has a base underneath the sidewalk. This base has a thickness and it has an extension. Inside edge, 0.5. 0. Allows me to give that flexibility. Is there a little overlap? Typically there is. Is it 6 inches? Maybe 3 inches, maybe 4 inches. Maybe it is just flat out, just zeroed out. I have that capability. I have that flexibility of putting what I need. And you'll see that that daylight right in there, not really daylight, where this meets up, it automatically ties in properly. So it will go up and around. You don't have that, oh, I got an overlap right here where the base extension came out into the boulevard. It works itself around it. Sidewalk with boulevard from right of way, it does the same thing as the sidewalk with boulevard, but again, instead of starting from the inside and working your way out, I have the ability to start from the outside edge and work my way back. And you see all that information right in here. Same capabilities, it's just now when you're tying back in, you tie back in here. So this is your targeting. So now your slop, your air, if you want to put it, is on the inside boulevard instead of the outside boulevard. Because I need, maybe this is at the right-of-way line, or maybe this is at top of ditch, and I need all this to be working my way back. But when I get to my top back of curb, all the slop needs to go in here instead of up in here. But other than that, the extensions are the same, the depths are the same, everything else is the same. Targeting, the 3 spots, still the same. Last two, MnDOT Curb. I built this because I live in Minnesota, and very similar to the general curb, I have the ability to come in and select it, and now I can actually select what style curb do I want, B, V, D, or S. And if I switch to D, it automatically updates to that proper size. And then S. What this does is it takes predetermined values, so now that user doesn't have to come in and say, oh, I need B612, so my gutter width needs to be 12 inches, my top of curb needs to be 6. I just come in and I set everything up to do B style curb. Now this is set up to be default 6-inch curb. It's not that common to have 4-inch curb up here, so it's usually always 6-inch. So we went with B612, D 6-inch, V and S on there. But I come in, set the cross slope of the gutter width. It is predetermined to be 12, 18, 24, 30, or 36 inch. I can't have a 15.5-inch gutter on there. The standard templates for MnDOT Curb is 12, 18, 24, 30, and 36. My sub-base depth, my sub-base extensions on there, extend a foot, depth, half foot, sub-base, 1 foot there. So I got half foot here, another half foot puts me here, and then the cut slope in there. Make the cut slope 1:1, make it there, make it 0.25, comes in there, 0.5. Now, as I'm grading out the site to prep for the road, it's not just a straight up slope, it's got some taper to it. So now I have the ability to control that taper. If you choose a curb, D36, well, there is no D 36-inch curb. You can't have a D style curb and 36-inch. You can't have it be 30 inches, but it will take 24. So if it makes something that doesn't match the standard template for MnDOT Curb, it just will not build, and it will show you that by not building it. But yes, B 36-inch gives me that. Then the last one is MnDOT Curb with sidewalk. And the biggest part about this is the sidewalk is the same thing as this sidewalk and that sidewalk. The curb is the same thing as this curb. The benefit between this is now I have the capability of calculating the common area. And this is the backfill. Hey, I put in my subbase, I put in my base, I poured my curb. Now I have to backfill so I can put in my inside boulevard, my sidewalk, and then my outside boulevard. As anyone has built a corridor before, it is very difficult to calculate an area based off of two separate subassemblies. You need to do the calculation off of one subassembly, and that's what I have here. So when I come into the properties of this subassembly, you will see curb. B style includes sidewalk. Yes or no? No. We don't want to include the sidewalk. We'll move that out of the way. And it eliminates the sidewalk. Oh, no, we need the sidewalk. But you know what? We don't need to calculate the common area. I don't really care about the common. It gets rid of it. Oh, no, we do need to calculate the common. So it comes back in here. There is my curb, again, my subbase, my base, my boulevards, my cut slope, sidewalk width. All this is standard information on here. But the other thing on here that we have is we have the shape code. There is the base, subbase. Here's my common. So if I come in and call this topsoil, REA, that gives me the, well, and of course I picked the same color that it already was, white and white. So I'll come in and I'll change the common to be, instead of topsoil, we will make it base so it comes out blue. And then I'll make sure I spell it right. So now it comes in with the correct color if it was base. What this allows me to do, again, with the custom codes, I can calculate what I need it to look like. I can have it be displayed the way I want it based off the code set style. And again, with it having a custom shape code of maybe common or backfill, when I go to get quantities, I can say, hey, give me the shape for backfill or common, and it will calculate how much area I need based off of either conic or averaged end, how much dirt I need to put back into the hole to finish the rest. So these are the 12 subassemblies that come in the CPP. Currently, it is free. I believe it will be free from here on out. So go ahead and download these things. They're free for you. But what this does is it allows you to go above and beyond. So first, go out to ctcsoftware.com, find the Corridor Productivity Pack, go ahead and click on that. It's going to say download for free. And you're going to download it. It's going to give you a zip file. You'll extract the zip file. And then inside the software, you do the standard. I always do it from the tool palette, import subassembly, give it a location. There are my imperial. There are my metric. There are my MnDOT specific ones. I just select them all. I tell it to go onto the CPP tool palette, which I might have to create a new one on there. New tool palette, CPP, put them all in there. I came in, put a text with a spacer, imperial, and then MnDOT, and they all come in. But what does this package do for you? Well, it helps when you get subassemblies that will meet the design intent. I don't know how many times I've talked to someone, they said, well, it's close enough. They'll make it work out in the field. Well, if we give them something that is the way we want it to look in the field, then they won't just make it work. They'll make it per the design. So having custom subassemblies allow us to meet the design intent. a lot more easier than just getting it close enough. What this also means is typically I'm spending less time building assemblies, because now maybe I don't need to do conditional subassemblies, maybe I don't need to do multiple regions, which means I'm spending less time building those assemblies or those corridors. Third, you have the PKTs. If I come back in to that zip file that I extracted, there is a PKT in there. Subassembly Composer comes with the software, with Civil 3D. You can open up that PKT and you can customize this a little bit further above and beyond what is already here. Maybe you want the top of the sub base to have a different slope, cross slope, than the gutter. You can come in there and make that quick adjustment on there. Maybe you don't want the outside edge of travelway point code to be customizable. You want it hard coded. You can very easily just go into that PKT and hard code it and then remove it from the properties, and now someone won't have the capability of making an adjustment to it. And then finally, you can utilize ATG as a source to build additional custom subassemblies. Maybe these 12 got your brain thinking. You said, well, what if we had this? What if we had that? We have the capabilities of building custom subassemblies for you if you don't have the time. Maybe we're talking rail. Maybe we're talking airports, taxiways, runways. Maybe we're talking water channels. So maybe we need canals and we need to build something, channelways, something along that line, retaining walls. Maybe the out of the box just doesn't cut it. We can build a subassembly that will meet your needs. So take those 4 things, subassemblies to meet the design intent, which means less time building assemblies and corridors. Modify the PKT to tweak them even further. I do recommend that you make a copy of it and then tweak it. And once you know that it works, then you can overwrite the other one. And then if you get stumped, if you just don't have the time, utilize ATG as a source to help build that additional custom subassemblies. With that, I'd like to thank everyone for attending. I hope everyone got something out of this. Again, the CPP is free. Go to CTC Software and download it. Give it a try. If you have any questions, concerns, give us a call. Other than that, keep an eye out on our website for future webinars for the 2020 season.